Good morning. Are you hear my voice? Students, please
Yes, sir.
respond. Yeah, this voice
Yes,
is
sir.
clear.
Yes, sir.
Okay. Today we just go through the remaining part of the Unit 5. I think Unit 5 we have completed different MOSFETs, right? DMOS and EMOS and their characteristics are studied in the last class. Now, and we did some problems also, and the problems will continue the next week after completing this syllabus, right? Now we'll just go to the Unit 5, the special purpose device. The special purpose device we have here, different device LED are there, UJT is there, and the CR is there, photodiode, and solar cells. Right, the first one is the LED. LED means light emitting diodes. I think this you have seen already in different decorations, right? LED everywhere in the adapters also, and red light is glowing when it is on. That each indication on electronic devices is done with the help of a LEDs, right? So LED is an optical diode. LED is an optical diode which emits light when it is forward bias. Which emits light when it is forward bias. See the symbol here. So simple diode symbol only, which consisting of a cathode and anode, right? And when it is biased, forward biased, right, a light is emitted, right? How this light is emitted means when the junction is forward biased, what happens? As per the theory of a diode, what happened? Enormous amount of holes are crossing the junction, right? Junction electron holes cross చేస్తాయి తర్వాత ఎలక్ట్రాన్స్ కూడా క్రాస్ చేస్తాయి హోల్స్ పి నుంచి ఎన్ ఎలక్ట్రాన్స్ నుంచి ఎన్ నుంచి పి సో దిస్ we can conclude that initially the semiconductor were divided into the conduction band and valency band, is it not? And there existing a gap, narrow gap of small gap of forbidden gap. This is the semiconductor, general semiconductor. If you take a p-type or n-type any semiconductor, energy level diagram, right? In this band diagram, if any electrons are there here and holes are there here, is it not? Holes are there here, electrons are there here. So if it is an n-type or p-type, whatever it may be, it's a special energy level is created here, right? If it is n-type, and if the p-type, a special energy level is created above the valency band, which is called as a acceptor energy level here, right? Is it not? So here number of holes are there, majority of holes, right? Here majority of electrons are there. These are all electrons, majority of electrons. So whenever these electrons, generally which is having the higher energy level, electrons are having higher energy level, when these electrons are jumped into the acceptor level or valency band, so which can be combined. Ade kada diffusion which is a process. P and diffusion process lo cheptunnamu, there is a lot of this is a P of 0 and cheptunnamu, this is a p type and this is a n type and cheptunnamu. So whenever here is the holes are the majority carriers, holes are the majority carriers, and the diffuse lines. There is some predetermined minority charge carriers are there. So this is the exponential decay. This has happened when the diode is in the forward bias. How this has happened means when critically comes here. We are assuming that here the electrons are at higher energy level and there is a gap is there and the cello holes are at lower energy level. So when the electrons is jumped or moved from into the this valency band or acceptor energy level and it fills the electron, it fills the hole, right? Each hole is not a simple hole, is it not? A covalent bond is there and then hole is there and then electron is there. Electron will indicate negative charge, hole will indicate positive charge. Is it not? This is the electron hole pair again. So each hole will represent here an electron hole pair. Each hole is represented here an electron hole pair. Right? So the electrons which are jumped from conduction bands to valency band or acceptor energy level, and they are filled this hole. They fill this hole. Right? They fill this hole. The hole fill yes. So therefore, when jumping from higher energy to low energy, the energy will be released. Some energy will be released. In simple diode, in a simple PN diode, this energy is released in the form of a heat that we already studied, right? Enormous amount of heat is generated under a large amount of current flow. In the current flow, the recombinations that take place and move particles are moving. Right? So recombination and collision, recombination, collision. This goes on happening. So that's why when collision is happened, again electron is released and it goes to the conduction band, right? Like this happened here. So this LED means a PN diode is a special purpose diode which is made up of with a optical materials, or photomaterials, optical materials. So this optical material generally will have energy released in the form of a heating simple diode, but in LED it is made up of a special material which is released with its energy in the form of a photons. So the special purpose the releasing of these photons. Generally, electron is moved from higher energy level to the valency band or low energy level. It fills the hole, and the existing heat is the energy is released. Good now, light is released. That light or energy is in the form of a photons. In the form of a photon. This mechanism again we are calling as a electro illumination. Electroluminance. Electroluminance. It is one of the generally we know that photo conduction, photo emission already we have studied. We have seen in physics. And like this here, electroluminance. Here the mechanism is called as electroluminance. This electroluminance is adopted. The principle is adopted. Right? Whenever energy is released from higher energy level, that is, the particle is moving from higher energy level to the valency band or conduction band to the valency band. So energy will be released. Photons will be released. This mechanism we are calling as electroluminance. We are calling as electroluminance method. So to generate this electroluminance process, we are using for optical materials. So these optical materials are optical materials. These optical materials are different optical material will generate a different color. If you take a gallium nitride, so it generates a blue light. Gallium phosphate, because we know that gallium is also a semiconductor, right? Gallium is also a semiconductor. And phosphorus is a pentavalent impurity. So P is mixed with the gallium. So gallium phosphate, which is generated with green. Like this, there are different colors is generated with different combination of a photomaterials, right? And if you take gallium nitrate, this will generate. It requires a forward bias of 5 volts. 5 volts is required to generate this blue light. If you take the green light, it requires only 2.2 volts is enough. 2.2 volts is enough to generate the green light using the gallium phosphate. Like this, there are many more there. If you take the same gallium nitrate if you take, and if you use it at a voltage of 4.1 volts, right, a white light will be generated, right? So like this, there are different ways you can generate different colors using this one, right? And we'll come to the construction here. Come to the construction of a LED construction. So this construction generally here we take different layers. So like this, there are different right. So this is a positive layer. This is a P-type layer, and this is a N-type layer, right? And there is a region in between. This is region. This is called as an active region. It's called as active region. So what happened here is the P-type will totally consisting of holes. Sit down. Holes. Number of holes are there. Because this holes is there, this side is we're indicating that a positive, all positive. I'm taking this shape is, I think you know very well how the shape is uh, that I will draw it, right? And this is the number of electrons. N-type is a majority of electrons. So if there is a gallium or arsenic, gallium arsenic or gallium, indium, like this, different materials. Here, this is the electron, number of electrons. So whenever the electron is moving, right, and enter here in this region, electron, and holes are here, right? So this electron will combine into this hole. This electron will combine into this hole, right? It's the so this electron will combine. So this releases the energy, right? This releases the light. This releases the photons, right? So first of all, I'm taking a P-type layer, right? And the N-type layer in between, a layer is called as active region is there. So in the active region, this recombination is taking place, right? Recombination, the electrons are recombined with the holes. So in this practice, the LED emits light all the way around the layered structure. Continually generates the light in the layered structure. So this can be shown in a physical symbol called like this. This is a physical symbol of an alien. These are two electrodes, which is one is acting as a cathode, another one is acting as an anode, right? And here on this process, this active region is placed here, right? This active region is continuously generating the light, in all directions, generating the light. This is the symbol, physical symbol, right? So this is about the photodiode. So photodiode is operated on electroluminescence principle. The electroluminescence principle is nothing but an electron is moved, recombined, or filled. in a hole in the lower energy level. Or you can say that electron from the conduction band is moved and fill the hole in the valency band, and energy will be released. Right? That energy is in the form of the photons. Right? This mechanism is called as electroluminescence method. Right? So to generate this type of this type of photons or this type of light is generated, and we are using a photomaterials. Different photomaterials are gallium nitrate, gallium phosphate, gallium arsenate, phosphate, Ga, gallium arsenate, GaAs, phosphate, right? Like this, and this will be generated with different voltages, and I will list out the different voltages in your notes that I will send you. That. And coming to this instruction part, a P layer and N layer is placed here. P layer is fully holes, and N layer is fully negative chaos of electrons, and in between a region is placed. Right? In this region, just it is acting as an active process. Means acting is in this region, electrons are recombined with the holes. All the places, electrons are continuously recombined. The region we are calling as the active region. Right? When this active region is continuously recombined with the electrons and holes here, a continuous light energy will be released. Photons should be released. Right? And the physical symbol we are showing here. Right? And come to the characteristics, output characteristics of LED. Output characteristics of LED. So as we know, as the forward voltage goes on increasing, the light ray goes continuously going on. The light is continuously generated. That means it is proportional. How much of voltage you are generating, you are supplying, that much of light is generated. Right? So a linear relationship is generated in between. So the linear relationship is showing like this. Right? And voltage is forward voltage. Forward voltage is taken on the x-axis, and here is the light output. Light output is in milliwatts. Right? So a linear operation is linear relationship is that as the voltage goes on increasing, light intensity also goes on increasing. You can say that is a luminance are not true. Right? The luminance will be switched. Right? So this is about the LED, light emitting diode. Are you clear? Any doubts? So a light emitting symbol is like this. This is the symbol for the diode. That is the earlier I shown is the physical symbol. This is the physical symbol. Right? And coming to the next one is the photodiode. Are you clear up to this? Any doubts on this? Hello. Everyone is sleeping, I think.
No, sir.
But not we are not responding, na? I think you are doing some aggregation, right? Or doing something. Okay. So next one is the photodiode. Photodiode is also similar here, but photo LED will operate under forward bias, right? LED will operate under forward bias, but photodiode is operate under reverse bias. What is the difference? LED generates the light in the forward bias, but photodiode is a semiconductor PN junction device whose region of operation is limited to the reverse bias region only. Reverse bias region only. Right? That is different. Photodiode is LED. Right? Generally, photodiode is connected in the reverse bias condition. Now, how the reverse bias PN junction is connected? Same way, the PN junction is connected in the reverse bias and operated in the reverse bias mode, right? But here, the deflection region width is large under thermal condition. It carries small reverse current due to the magnetic charge carries. Small reverse current means called as a saturation current. Is it not? Saturation current. LED means light emitting. Here photodiode means when the light ray falls on this diode, I will show this one, symbol for this one. It is operated in the reverse bias. This is anode and this is cathode. So earlier we shown this symbol as like this. A light ray is showing as arrow mark is here. That means light is emitted, but it is light is false on this. Is it not? When the light ray falls on this, fall on the diode at the junction, then the diode becomes reverse bias. When the diode becomes reverse bias. Under reverse bias, what happened here? So, how to make this reverse bias when the light falls on this means here we are using a photoconduction phenomenon. We are using a photoconduction phenomenon. What is photoconduction phenomena? Whenever any photo material exposed to light, whenever any photoconducting material exposed to light or light intensity, then the conduction is possible. Conduction is possible. Such type of diode or process is called as a photoconduction. So I'm very simple. A PN diode is stated here. This is a junction, right? And reverse bias. This is called as a barrier potential generated. Barrier potential generated when the light ray falls. When the light ray falls, right? So when light ray fall on this means what happened? The reverse bias means more and more magnetic charge carriers are generated, right? Magnetic charge carriers are generated. So when the magnetic charge carriers are generating holes, right? Holes. So electron, hole pair, and a hole atom, right? These are the magnetic charge carriers. Magnetic, electrons are the magnetic charge. So there is a flow of magnetic charge carriers from P to the N and then N to the P whenever the light is formed. So how this light is converted into this means here at the junction region, this region is coated with a photo material. Photo material. This junction is coated with a photo material. When light is incident through the glass window, so this total will be closed with the glass, right? This PN junction, the diode is there at the junction region. This is closed with the glass, and this inside this glass, this is coated with a photo material, right? So closed with the window on the PN junction. Photons in the light bombard the PN junction. So whenever this light is touches this glass, some energy is imported into the valency electron. The energy is converted to photon energy which is released from the light. From the light. This light is light energies touches this glass, and this some amount of optical energy or light energy is given to the electrons which are nearby the junction, right? So that is called valence electron. This valence electrons will again broken the covalent bonds nearby junction. That is, we know very well about the what is the phenomenon occur in the reverse bias junction, right? As reverse bias is going on increases, the more and more electron voltage on this one, right? Break down here and only minority flow will be there. So more and more electron hole pair on n side is created. N side electron hole pair means holes are created. On p side is electrons are created. So this flow will happen from p to the n and n to the p. Electrons are moved and fill this electron hole pair, right? And this constitutes a flow of current, right? This constitutes a flow of current. How much of intensity of light you are concentrated on this glass region, that much of energy is transferred, that much of photon energy is transferred to the electrons, and more cumulative processes happen here, right? And this cumulative minority electrons or minority holes will cross a junction which constitute a current or which constitute a voltage. That voltage is called as a reverse voltage. So here we are generating the voltage. Photodiode is generating. Just keep this diode into the sunlight, right? And you connect your two wires and keep your battery here. Automatically charges the battery, right? That is called a photocell. That is called photocell. Nothing but a photodiode, right? And coming to the, this is a symbol and this is a constructional diagram and operation. And coming to the characteristics, because it is operated in the reverse voltage and the reverse current, so automatically I am showing this in the characteristics here. So this is I am showing in the on this one. This is the current on this one. This is current is I in microamps. Current always, because the reverse current always in microamps, and this is the voltage of reverse voltage VR, right? And for different lumens, what is the reverse saturation current generated in the PN junction diagram? మనకి ఎలా జనరేట్ అవుతుంది? Power bias ఇలా వస్తుంది, reverse bias నుంచి ఇలా వస్తుంది, కదా? Now just if it is better or worse, it goes like this. Similarly, as the reverse current is increasing, we are getting it like this. As the intensity goes on increases, this is a intensity can be lux. Lux is the unit of light intensity, right? If there is no light is formed here, there is a dark current is formed here. If the light, there is no light intensity is placed here. ఈ జంక్షన్ మీద ఏ లైట్ ఇప్పుడు పడలేదంటే ద కరెంట్ జనరేటెడ్ అట్ ద టైమ్ వెన్ ఇట్ ఇస్ కాల్డ్ as డార్క్ కరెంట్, రైట్? అప్పుడు యూఆర్ గెటింగ్ యాజ్ జీరో లూమినెన్స్, రైట్? జీరో లూమినెన్స్ పర్ మీటర్ స్క్వేర్, రైట్? Zero lumens. As the current goes on increasing, then the current also increases. Dark current means zero current. Current is zero, right? So here it is 10,000 lumens per meter square, and this is 15,000. That much of light is falls down on this one. Lumens per meter square and goes on. This is 50,000 lumens per meter square. So as this intensity is increased on this junction, automatically the current, reverse current is also goes on increasing. So this is the characteristics of a photodiode. Are you clear now? So photodiode is a generating the reverse voltage. Reverse voltage generation. Reverse voltage generate just like a, you can call it as a photocell. Photocell, right? So whenever the light falls, automatically the conduction falls. So the phenomenon included here is the photoconduction. Photoconduction phenomenon. So because of this photoconduction phenomena, the current flow in the PN diode, this current flow will constitute the reverse voltage of VR is generated here, right? So when you go for a characteristic curve, you can draw the curve between the reverse voltage to the current, reverse current generated, right? The current is in the microamps. So for different luminance, or lux per the intensity of light, can be measured in lux or lumens per meter square. 10,000, 15,000, that is the intensity of light. If you go on increasing the intensity, then the reverse current goes on increases. Right? So this is the characteristic of. And at what luminance, on the zero luminance, no light falls on this junction. No light is fallen on this junction. The current generated is called as a dark current. Right? Minimum current is generated. That is called as a dark current. So this is about the photodiode. And coming to the advantages of a photodiode, can be used in a variable resistance device. Used in variable resistance device. And number two, highly sensitive to light. Whenever the high sensitive light eక్కడ యూస్ చేస్తున్నాము, next is the third one, the speed is also very high. Right? So these are the different advantages. So advantage variable resistance now use చేసుకోవచ్చు. Right? Variax variable resistance use చేసుకోవచ్చు. And light sensitive to highly sensitive to light. So because of high sensitive to light poverty, it generates a large amount of reverse current. And coming to application, Burka alarm system you can use it here. Counting system కూడా యూజ్ చేయొచ్చు, and photo detector గా యూజ్ చేయొచ్చు, and logic and switching and demodulation circuits వాడచ్చు. Logic circuits లో యూజ్ చేయొచ్చు, switching circuit లో యూజ్ చేయొచ్చు, and demodulation లో యూజ్ చేయొచ్చు. Especially this can be used in optical communication system. So in optical communication system కూడా it can use. Right? So this is about the photo. So any doubts regarding this? Are you hear me or not? Please respond. Are you there in the classroom or
Yes, sir.
somewhere else?
Yes, sir.
Okay. Okay.
Yes, sir.
So two devices to complete now. One is called as a photo LED and another is a photo diode. And one more is called as a UJT, unit junction transistor. The third device is unit junction transistor. UJT. Unit junction transistor. UJT, unit junction transistor. The name indicates that only single junction is there. Only one junction is there. Is it not? Only one junction. Right? Generally, this contains a base bar is there. This is constructed with a N-type base bar. So a base bar is taken out here. This is called as a N-type bar. Right? On this N-type bar, we are just taking the two leads. Two leads are taken out. These two leads are called as one is the two base terminals. You can also call it two base terminals. This is called as a B1 terminal. This is called as a P2 terminal. And then a small amount of P material is placed here. So this is N-type bar. This is the N-type bar. On this, a small amount of P material is placed here. From this P material, I'll just take it out. A lead, an aluminum rod is take it out. This is called as a emitter. This is base 2. This is base 1. Right? So an entire board is taken. On this entire board, a small P material is placed here. Small P material is placed here. From this P material, the rod is taken out. That is called as emitter. So it is a three-terminal emitter, base 1 and base 2. This I can show in some other way. Now you can understand the operation better. So this is the entire bar. On this entire bar, I am placing a P material here. I am taking a P material here. And this is the N bar. And rods will be used here. Take it out. This is called as a base 2. And this is called as a base 2. Like this also you can show the construction diagram. And a rod is taken out here, aluminum rod, a small aluminum rod, which can be represented as emitter. So it's three-terminal, two-layer layers. Only P and N layer is there. Is it not? And the symbol for this one is the symbol is shown here. Simple like a FET only. And a line is showing, and the arrow mark is moved towards the base one, towards the base one. So base one. This is base 2, and this is emitter. Right? Arrow mark is bending and it's showing towards the base 1 line. This is the symbol for a FET. Right? Now I want to operate this FET. Generally, a voltage is applied in between base 1 and base 2. The voltage is applied between base 1 and base 2. This voltage is called as VDD. This is positive. This is negative. Called VDD. Base to base voltage. Right? The base to base voltage is applied between base 2 and base 1. Are you clear in the construction? Construction means you take the entire bar. On this entire bar, you just place a small amount of P material or sandwich P material or doped traveling impurities to form a small region of P material, right? And from this B region, when B is taken out, that is called emitter, and from the two other ends of the N region, two leaves will be taken out, base 1 and base 2. You can interchange this base 1 and base 2 also. Just like a PET మనం ఎలాగైతే డ్రైన్ అండ్ సోర్స్ ని ఇంటర్చేంజ్ చేసుకోగలము ఇక్కడ కూడా మనం ఇంటర్చేంజ్ ద బేస్ 1 and base 2, right? And this is called as a ohmic contact also. This is called as ohmic contacts. Ohmic contacts. Okay, right. So the condition here is always base 1 is positive. So always an amount of base voltage VBB is applied between base 1 and base 2. And the emitter junction is always forward bias. The condition. Emitter junction is always forward bias. Right? The emitter junction is always forward. This voltage is called as VB, emitter voltage. Emitter junction always forward bias. Emitter junction forward bias means Here, the emitter is a p-type material, so P is connected to the positive and N is connected to negative. So that's why this junction will become, this junction here, the junction which is formed here, this becomes the forward bias, right? And between base and base 2, the voltage is applied called as a VBB, base to base voltage. Base to base voltage. Okay. So this is the construction diagram and the circuit here. Now I want to construct this with a symbol. I'll just show this using the symbol. So this is a circuit. So in the circuit, we have applied a voltage of VBB between base 1 and base 2, and an emitter voltage of VB is applied from emitter to base 1, right? So this makes the emitter junction is formed, right? This is a construction circuit diagram, and this is circuit diagram. So initially, when I is equal to 0, what happened? When I is equal to 0, means I am not applied. There is no base current is flowing here. So A base current లేదు a current flow కావడం లేదు. I is equal to 0 అనుకో, for example. Instead, when I is equal to 0 means the resistance between the base 1 and base 2 called as inter-base resistance. The current లేదంటే ఏం meaning ఏంటి వాటికి? What is the meaning of this? No question of bias here. So the entire one is simply an n-type bar. Simple and n-type bar. So the n-type bar can be showing here inter-base resistance. Inter-base resistance is present. That is represented by RBB. Inter-base resistance is represented by RBB. So what I am doing, construction part, n bar is taken. On this n bar, P is material is sandwiched on any one of side. It can also be but only one side. UJT like the రెండు సైడ్ వేసి కదా 42 జంక్షన్స్ వచ్చాయి కాబట్టి ఇక్కడ న్యూ జంక్షన్ కాబట్టి ఒక సైడ్ వేస్తాం.
Sir, your voice is breaking, sir.
Now it is okay. Hello.
Okay.
Are you hear my voice?
Yes, sir.
Yes, sir.
Okay, sir.
Yeah. So in the FET, actually we can place the two P regions on the side, but in UJT we keep only one P material on the side, so that only one junction is present here, and this one junction is there, and that the junction is we have to make it as a forward bias, right? So initially I am not applied any voltage here, simply I is equal to 0. I am not applied, I becomes 0. When I is equal to 0, there is existing inter-base resistance, right, is generated. That inter-base resistance can be represented by here two resistors, and this resistance is called as RB2, and this resistance called as RB1, right? In between, then a diode is connected. Diode means ఎందుకు diode చూపిస్తున్నాము because this emitter junction is a forward bias కాబట్టి ఇక్కడ ఉన్న emitter junction forward bias PN junction కాబట్టి is nothing but a PN diode కాబట్టి I am showing a diode D ఒక diode D గా చూపిస్తున్నాను. So this is the equivalent circuit for a UJT. UJT equivalent circuit. This is B2 and this is B1. So when I is equal to 0 means I am just replacing the FET UJT as a diode is connected in between the two base resistances, right? So RB1, RB2 is a base resistance 2 and RB1 is a base resistance 1. When I is equal to 0 means RBB is equal to I is 0 there is no question of any parallel action here. Simply these two will act as a serial. So RB1, RB2 plus RB1. ఇక్కడ కరెంట్ ఏది ఫ్లో కానప్పుడు మనకి కనెక్షన్ వేస్ట్ ఇక్కడ కాబట్టి ఈ రెండు రెసిస్టెన్స్ సిరీస్ లో కనెక్ట్ అయి ఉన్నట్టుగా మనం అజ్యూమ్ చేసుకోవాలి. సో when this is in series means the total resistance is called as inter-base resistance, which is RB is equal to RB2 plus RB1. RB2 plus RB1. If I applied any current here, now I am applying voltage here. This is not equal to 0. Now, when I is not equal to 0, means I am applying some voltage here. What happened? This junction will become forward bias. When this is forward bias, what happened? There is existing a voltage drop across the junction, right? There exists a barrier across the junction. The junction is a barrier through to VE is increased at suppose 0 next to 0.5 volts. So 0.5 volts it creates like this. Right, next to 0.1 1 volt it goes like this. Next 0.5 volts 0.2 1.5 volts it goes like this. See what happened here. So this region of barrier region goes on spreading into the N region. The barrier is here, goes on spreading in the N region because of this applied forward voltage VE on this emitter junction. So on forward bias, the barrier or depletion region is spreaded like this. Now when you spreading out, already we have seen in the FET, correct? Because the entire bar is divided into number of resistors. The entire bar is divided FET lo manamu divide chesam. Each resistance is all equal resistance to chupicham, right? Ohmic region lo. So this resistance will have voltage drop of V1. This resistance up to this resistance V2. Up to this resistance the voltage drop is V3. Up to this resistance the voltage drop is V4. V4 is far greater than V1. కాబట్టి voltage ఇక్కడ more voltage accumulate అవుతుంది కాబట్టి డ్రాప్ అవుతుంది కాబట్టి this voltage always try to make this junction be more reverse bias కదా. కాబట్టి మనకు డిప్లేషన్ విడ్త్ కూడా ఆ డిప్లేషన్ లేయర్ కూడా ఇలా స్ప్రెడ్ అవుతుంది, రైట్. కాబట్టి ఇక్కడ this total bar n bar is replaced by here we are inter-base resistance గా రీప్లేస్ చేస్తాం. కాబట్టి ఇక్కడ మీకు ఏమవుతుంది, existing potential drop of across the RB1 లో పొటెన్షియల్ డ్రాప్ వస్తుంది, వోల్టేజ్ డ్రాప్ వస్తుంది, ప్లస్ RB2 లో వోల్టేజ్ డ్రాప్ వస్తుంది. సో మనకి మెయిన్ ఇంపార్టెంట్ ఇక్కడ RB1 లో ఉండే పొటెన్షియల్ డ్రాప్ ఇస్ ద మోస్ట్ ఇంపార్టెంట్ బికాస్ ఇట్ ఈస్ వెరీ నియర్ టు దిస్, రైట్, వెరీ నియర్ టు ద emitter, right. So the voltage drop across the RB1 is called as VRB1 is equal to n ఈ వోల్టేజ్ ఇక్కడ కనెక్ట్ అయింది కదా, అప్పుడు వోల్టేజ్ అప్లై చేసినప్పుడు దిస్ బికమ్స్ ప్యారలల్ సర్క్యూట్. ప్యారలల్ సర్క్యూట్ లో ఏం చెప్తాము, ఈ రెసిస్టెన్స్ లో వోల్టేజ్ డ్రాప్ కావాలంటే ఏం చేయాలి మనం, వాట్ ఈస్ ద టోటల్ అప్లైడ్ వోల్టేజ్, రైట్. ఎంత వోల్టేజ్ అప్లై చేస్తాం ఇక్కడ, VBB అప్లై చేస్తాం. VBB is the total voltage applied on this total base resistance. కానీ మన కావాల్సిన రెసిస్టెన్స్ ఓన్లీ డ్రాప్ ఇక్కడ మాత్రమే కావాలి. సో RB1 is equal to VBB into where we are measuring across the RB1 resistance. Now RB1 by what is the total resistance of this circuit? RB1 plus RB2. RB1 plus RB2. So this is the resistance drop across the baseline. Voltage resistance, voltage drop across the baseline, right? And this can be again replaced by, this part is replaced by VDB beta into VDB. Beta into VDB. Beta అంటే ఇక్కడ RB1 by RB1 plus RB2. Beta is equal to RB1 by RB1 plus RB2. Beta is equal to RB1 by RB1 by RB1 plus RB2. Is equal to RB1 by RBB. RBB is equal to ఇక్కడ చెప్పాను RB2 plus RB1. ఎందుకు under I is equal to 0, this total resistance are equal to RB1. So this is called as a eta is called as a intrinsic standoff ratio. Intrinsic standoff ratio. Okay. So this is the operation of a UJT, and this is the equivalent circuit of a UJT. This part is called as the equivalent circuit. Equivalent circuit of a UJT. Right. So voltage is V is applied here, current is equal to V is flowing here, right? And there is this way drop across this is VB1, VRB1. VRB1 is existing here, right? So this is the simple construction and operation of a UJT. And the characteristics and things we will see in the next class, because I think the time is already reached, right? Okay, now, so tomorrow we will continue the characteristics part. If you have any doubts, you can ask. Okay, now, shall I stop? Respond.
Yes, sir.
Okay, sir.
Yeah. Okay.
Sir.
Okay. If you no doubts, then you can leave.